Welcome everyone to the Geometry Mailbag. We have a question that's been submitted, and if you want to submit a question, feel free to do so either through email or as a comment. But this particular question is a geometric concept on similar triangles. Let's go ahead and read it and see what we can do. We have here the Washington Monument. At a certain time of day, a 1.8 meter tall person standing next to the Washington Monument casts a 0.7 meter shadow. At the same time, the Washington Monument casts a 65.8 meter shadow. How tall is the Washington Monument? Now, let's go ahead and kind of give us a little drawing. I always like drawing things to get a better idea of what's going on. Okay, Washington Monument looks something like that. This isn't perfect, but just want to get the general idea. Okay, something like this. Okay, looking good. Okay, there's our Washington Monument. Now, this thing casts a shadow that is 65.8 meters long. Okay, now we have a person standing nearby, and he's going to be blue. Okay, there he is. And we know that he is 1.8 meters tall. So we're going to draw him, 1.8 meters, all the same units here. We don't have to convert anything, that's good. And he only casts a shadow that is 0.7 meters. So here's his shadow, that is 0.7 meters. Now, it's asking us to solve for the height of the Washington Monument. So we want to know that height, we'll call it X. We could call it M. Let's call it M for the monument. I like that better. So we're going to call it M for the monument. Now, here we have an example, a classic example of similar triangles. We could complete these like this. So we have this big yellow triangle would be the Washington Monument's triangle, and then we could create another like little green one right there. And as we draw these off to the side, sorry. I don't know if that's correct. Let me just redraw it just in case. So here we go. Okay, and I'm going to draw in the dimensions I know. And then this is my unknown dimension, M. And then here's my little triangle, not to scale. Okay, so don't yell at me, please. And we have 0.7 and then 1.8. Why are these, first let's talk about why are these congruent. Well, these are congruent triangles because one, we're assuming they're standing at 90-degree angles. Okay, so there has to be a second angle that makes them congruent, and that's here. Okay, so here is the same angle because that is the angle of the sun. The sun comes down and it creates the same shadow everywhere. That's the whole idea behind shadows, is that the sun creates similar triangles with anything that's standing at a 90-degree angle. Okay, with that known, we can compare the two triangles. Okay, so we can put the big triangle on the top and we can compare it to the little triangle, okay, on the bottom. That's the person. So we can compare, once you have a fraction set up with what we're comparing, on either side, whoops, didn't want that. On either side of our equal sign, we have to compare two things too. We can compare the shadow on the left side of the equal sign, and on the right, we can compare the height of whatever, either the person or the monument. So this is the height. So we have the shadow and we have the height. So let's go ahead and fill in our blanks here. Here for the shadow, we know the shadow is 60, oops, nope. Sorry, yellow triangle is the big one. Okay, so 65.8 is the shadow. The height of that triangle is unknown. Okay, so that's on the top. For the bottom, we have the small triangle, the little guy, okay, the person. We know the shadow is 0.7, and we know the height is 1.8. Okay, just from this, we can see because this person is taller than his shadow is long, then we know the monument is going to be taller than its shadow, okay? So we need to expect a number that's bigger than 65.8. From this point, okay, I'm going to erase some of my structure here just so we can more easily cross multiply and then divide. So here we have 0.7 times m, I'm going to leave this green, equals 65.8 times 1.8. Okay, now I need my calculator. I'm not great at multiplying decimals in my head. Please forgive me for that. Times 1.8. I'm not a human calculator. What can I say? 118.44. When I do that multiplication and I have 0.7, I'm going to leave the m this color. Okay, now I'm going to do a one-step equation from here to get the m by itself. So I divide by 0.7. I have the m by itself. Our monument is going to be 118.44 divided by 0.7, so it's going to get even bigger. I get 169.2 meters is our height of the Washington Monument. And that's how you do this problem. This is a good word problem relating similar triangles. The key is the sun hits the same angle, 90-degree angle there, and then we set up a true proportion. Keep in mind what we keep on the top has to be on the same. Both sides equal sign. Bottom has to be the same on both sides equal sign, and you have to compare the same thing on the left and on the right. As long as you're consistent there, you'll have no trouble at all. Thank you for this mailbag message, and I hope to get some more in the future. Stay tuned.